Hello students, good evening. Let's start with a very dynamic subject as it is a dynamic programming. So I hope you guys enjoy it. And today in this lecture, basically what we are going to be discuss, we are going to discuss about the assembly line scheduling. Okay. And what is this assembly line scheduling problem and how we can able to solve this assembly line scheduling problem by the help of dynamic approach. Okay. So first of all, what we have to do here, you can see the manufacturing plants have the assembly lines. Example, automobile factory has two assembly lines. So you can take example of the automobile factory and of the two assembly line. So here you can see clearly assembly line 1, assembly line 2. So engine fitting, body fitting and painting. Suppose you are taking the problem to solve it. And in the assembly line 2, you taken with the engine fitting, body fitting, painting. Okay. So you can see here main thing is in both the line, same thing is happening. But what's the difference? We are going to check how this assembly line scheduling problem is working here. So each line has end station. So you can see each line is having the end stations S1, S1, 2, S1, 3, S1, N. Then for the second one, S2, 1, S2, 2, S2, 3, S2, N. So you can take any number of S stations or N number of stations or N number of points, anything you can tell here. Okay. So based on your question, you have to analyze how you're going to be applied. So corresponding stations are S11, S21, perform the same function. Example, engine fitting, but can take different amounts of time, A1J and A2J. That means it took different amounts of time. Okay. Entry times are E1 and E2. Or else you can tell execution time 1 for the assembly line 1, execution time 2 for the assembly line 2. Okay. And exit times are X1 and X2. So this is the execution time, or you can tell the what entry time, and this is the exit time. Okay, X1 and X2, and these are all the stations. So here we'll see how this problem can be solved. Okay, I hope you clear with this basic understanding of the problem. What we are going to do here, two assembly line is there. For that, one entry point is there. For the assembly line 1, assembly line 2 also one entry point is there. So same way for the assembly line 1, one exit point is there. Same way for the assembly line 2, one exit point is there. In between, there are certain n number of stations are there. That means to do the function or to do the same function. Okay. So this is the concept. So now we'll move with the next slide. So in this slide, you can see manufacturing plants of the assembly lines. Already we understood that it is having the two assembly line. Okay. So here already we saw with that. So here what we have to do in this particular two lines, we are going to be work over the particular S1, S2, S3 up to Sn. Okay. And an automotive constraint should be applied. Can stay on the same line at no additional cost or transfer to the other line. So we have to check whether we have to stay in the particular same line or no additional cost going to be applied, or we have to transfer to other line so that the cost will be reduced. Okay. So in this programming, best for what we are analyzing, first of all, we are going to be reduce the time as well as cost. Okay. Then transfer to the other line, cost after Sij is to Tij plus 1. Then it will be analyzed over the recurrence of the time. Okay. Then problem is what? What station should be chosen from line 1 and line 2 in order to minimize the total time through the factory for one car. Okay. So main problem is what? Here this is the main problem. Try to understand. What station should be chosen? What station we have to choose from line 1 and line 2 in order to minimize the total time through the factory for one car. So we have to minimize the total time through the factory for one car. Okay. For that only we are doing here. We have to do the cost optimization, as well as we have to do the time reduction. Okay. So this is the context of assembly line scheduling. Okay. So here you can see enumerate all possibilities of selecting stations. So we have to check with the all the possibilities because here also S1 to Sn is there. Here also S1 to Sn is there. Compute how long it takes for each case and choose the best one. So here we have to check all the cases, okay, iteration, all the iteration. Like suppose t n station is there means we have to check for the n number of iteration, okay. So once checking all the iteration, then compute how long it takes for each case. You have to check one case, how much time it is taking. Then you have to check the other cases. So according to that, the optimal case, the optimal solution, and which will have the less time, that we have to choose here. Sorry. So 0 line 1, 1 line 2. Okay. So we have to take the constraint like this. 0 as line 1, 1 as line 2. There are 2 to the power n ways to choose the station. Why 2 to the power n ways? Because based on the number of iteration. And exponential time complexity here. Obviously, whenever we are going with the assembly line scheduling problem, if we want to solve the particular problem, it will be moved with the exponential time complexity. Why? Because you can see we can't take the decision itself in the initial time. So what we have to do, we have to check up to the n times. Okay, that is n stations. That is what here the exponential time complexity analysis will be happen. That means it will be take more time. Accumulation of error will be more. Okay, because what again and again we are checking. That is what exponential time complexity analysis will be high. Okay, so. Basically, whenever we are understanding the optimal substructure is what, that basically what and how it is working. So an optimal solution to the problem contains within it an optimal solution to the subproblem. Already you can understand from the line itself, optimal substructure. So you can get this sub problem from the optimal solution. Whenever you will be get the optimal solution from that itself, you can get the subproblem. Suppose the fastest way through S1j is through S1j minus 1. We must have taken the fastest way from the entry to S1 to j minus 1. What is the meaning of it? Whenever we are analyzing a particular line, that time we can take over the particular like S1, S2, Sn. So you can apply the formula S1j minus 1, A1j plus T2j minus 1. Okay. So in this way, what you can do, you can instead of going with all the possibility solution, you can analyze with this S1j minus 1. Okay, that will be shows the fastest way from the entry S1j minus 1. Similarly, you have to check for all the cases, but here you have to check with one by one. Okay, so that is overlapping sub problems, because if the same context like the entry is 2 times, okay, so it is taking more time, but the overlapping of the sub problem is happening, so that here the optimal substructure, that means that should be inside the optimal solution. Again, it will be create the overlapping. Okay, so that is about the optimal sub problem. Like here you can see easily, you can understand A1j minus 1, it is coming with the S1j minus 1, S1j, A1j. Then again 2, line 2j minus 1. Okay, that is what, again if you are going with the line 2, A2j minus 1. So that is what it is telling, overlapping sub problem. So sub problem is overlapping. Okay, so we'll move with the next slide. So in this slide, it is mentioned what is the F-stat, fastest time to get to the entry factory, whatever is discussed here. Okay, Fij is fastest time to get the station Sij from the starting point, and stat, the line number which is used to exit the factory from nth station. Lij is the line number 1 or 2, which station is used to reach Sij. Okay, so here what is objective function? You have to remember this formula. Objective function is f star equal to minimum of f1n plus x1 f2n plus x2. So based on this, you have to work with this particular objective function whenever you are trying to solve the assembly line scheduling problem. Okay, by the help of dynamic programming. Okay, because here dynamic programming main motto is what? This will be go with the optimal solution. To get the optimal solution, and it has to be do what? it will be go with the exponential time complexity. But here we have to get the optimal solution. For that only, we are working for this objective function. Okay. So recursively define the value of optimal solution. Now you can clearly this f1 of j, it is recursively define the optimal solution. E1 plus A1, I already mentioned, E1 is entry 1 time. Minimum of f1 and j minus 1 plus a1j, f2 j minus 1. Again formula. This is what objective function is applied. T2 j minus 1 a1j. This is for j equal to 1. Based on the iteration, it will be work. How many scheduling line is there? Based on that, it will be work. So f2 of j, e2 plus a2j. Then again, the objective function is there here. Then j equal to 1 if j greater than equal to 2. Then here you can see f1 and f1 of 1 is entry cost for line 1 E1 plus time taken at station 1 line 1. F2 1 is entry cost for line 1 E2 plus time taken at station 1 line 2. Then F1 2 is fastest way to get to station 2 on line 1 from starting point. Starting point, this is the fastest. F2 3 is fastest way to get station 3 on line 2 from the starting point. Okay. So this is about the fastest way to get the station 3. So this is about the objective function over the assembly line scheduling, how it is working. Okay. So next at each station you can see station 4, station 5 is there, F of 4. Then here line 1, line 2 is there, 2 of 3. Then 8, 5. Then minimum of, then if we are solving this particular problem, so here you can easily solve it. Minimum of 24 plus 8, 25 plus 5 plus 2, 32, 32 equal to 32. Then minimum of 24 plus 8 plus 3, 25 plus 5. Then minimum of 35 plus 35, 30. Then minimum, always we have to choose the minimum one. So here as it is same, so we taken as 32. So here the minimum is 30, so chosen as 30. Okay. So we have to check which is very minimum. Based on the minimum time, we have to choose it or minimum cost. Okay. So this is the answer. Which one is the minimum that you have to take it over the station. So here using bottom-up approach, first find the optimal solution to solve problem. So first of all, we have to find the first, we have to find the optimal solution to solve problems and use them to find the optimal solution to the problem. Then for j greater than equal to 2, f of ij depends only on the f1 j minus 1 and f2 j minus 1. Then f1 of j will be work over the f1 1, f1 2, f1 3, f1 4, f1 5. F2 j will be work over the f2 1, f2 2, f2 3, f2 4 and f2 5. And again it will be moved with the I1 j. So this is the iteration based on the line scheduling we have to move. So 1, 1 by 2, 1 by 2, again 1 by 2, 1 by 2. Then for the 2, again 1 by 2, 3, 1 by 2, 4, 1 by 2, 1 by 2. Okay. So based on this, you have to check the condition. And then again, you have to go through the constraint, how it is working. Okay. So here you see a complete example over the, here in the question it is mentioned f1 of j, e1 plus a1 1. Minimum of f1 j minus 1, a1 j, f2 j minus 1 plus t2 j minus 1 plus a1 j. If j equal to 1, j greater than equal to 2, then in this problem it is mentioned, you can see entry point, exit point. Based on that, again, you have to apply the this objective function and get the solution. Again, you have to check the F star, L star, 38, 1. So you have to check the minimum one, which one is minimum that you have to take it. Okay. So again, you can see in this also how it is working and how it is becoming the minimum one. Okay. Easily it is mentioned. All the constant entry exits, then how it can be replaced, how the minimal will be taken first. Okay. So first of all, here we have to choose which one is minimum that should be taken. Okay. So based on that, and we have to do the sum up. Okay. So this is about our assembly line scheduling, how it is working and how the objective function is working for the how we are computing. So any doubt, you can comment me in the comment section. I'll try to answer your doubts. Then we'll move with the so once this theoretical class and the basic concept will be clear, then we'll move with the one problem depthly and we'll understand how to make it. Okay. Thank you. Just understand the basic concept. Then we'll move in the advanced class I will thoroughly one by one problem I'll solve and make you understand properly. Thank you.